Central to all mining activity is the transportation of men, materials and equipment into and out of the mine. The means of transport are generally skips for ore and cages for men, materials and equipment. Both cages and skips are suspended by wire rope. This program will deal only with cages. In terms of safety and efficiency, the critical points in this conveyance are the positions of transfers in and out of the cage. Two factors play an important role at these points, namely weight transfers and rope stretch. Let's take a closer look at the effect of these factors and the situations they lead to, familiar to all miners. The cage descends, but as it slows, it takes time and repeated ringing of the bells to wait for the up and down yo-yo effect to stabilize and to jockey the cage into the right position. At 1,200 meters below surface, the men at the end of their shift cannot wait to get out. Two cages holding a total of 180 men adds up to a lot of weight and a heavy responsibility for the mine management. In this example, the cage is unsecured and the sinking effect is clearly seen as the load in the cage increases. This can lead to discomfort and distress for the men as they have to negotiate an unstable sinking platform, an inherently dangerous situation which no mine operation needs. The temporary meter scale attached to the side of this cage gives an idea of the rope stretch as the load increases. An uneven platform like this can lead to things like tripping and is never desirable. Let's see what happens in the event of unloading a large piece of equipment. In this case, it is a car loaded with cement bags. The cage floor and solid platform have been carefully lined up. The car is very cautiously pushed out. As soon as its wheels cross the rail gap and transfer weight out of the cage, the effect on the cage can be clearly seen.
Okay.
More bell signals from the onsetter, and the cage is carefully lowered into level position again, all taking time. After carefully checking the positions again, another push, and this time the back wheels transfer. And up jumps the cage again. Never mind the loss of time and inconvenience, it is also very hazardous, as the car could easily derail and spill its load. Here again the onsetter must lower the cage once more, so that it clears the back end of the car. Only now can the car be safely pushed all the way out. The danger of accidents and the loss of valuable time are abundantly evident in the preceding two examples. Does it have to be so? The answer is definitely no. The Levelok cage holding system, developed by Horn Hydraulics, is the complete solution to the problem. This system is simple, yet sure in action, light in weight, yet ruggedly reliable for the conditions in which it must perform. It is easy to install on any cage, easy to set, easy to adjust, easy to service, and simplicity itself to operate. Its components consist of a simple reservoir and pump unit, which is impelled by quick connection to the compressed air line available at every loading or unloading station. The pump actuating the hydraulic cylinder is mounted within the body of the cage holder, and when required to do so, actuates the arms which grip the guide rail. The jaw-like clamps of the Levelok hold the cage immediately and immovably, despite weight transfer variations and rope stretch, and hold it safely and securely until it is released. Here we see a test rig designed to measure the overload capacity of the Levelok cage holding system. Fitted in the rig is a 2.5-ton holding system. The compressed air hose is fitted and the jaws close as the pump is activated. Pressure is applied to the guide rail, simulating a cage load via a hydraulic ram. At 3 tons there is no movement of the rail section. Further pressure is applied, and as the gauge creeps up it goes through 4 and then on to 5 tons, and then only when it reaches 5.5 tons do we then start to get slippage. In other words, the Levelok is designed with a minimum 2 times safety factor. Let's see the action again. Here the cage has been leveled and then clamped with the Levelok cage holding system. This time there is no relative movement of the cage floor with the fixed platform as the men embark. With its built-in safety factor of double the maximum weight capacity of the cage, the vice grip of the holding jaws is solid and will not slip. Note that the floor of the cage is still held level with the fixed platform even after all the men have entered the cage. What happens when the Levelok is released? There is no sudden drop as might be expected. It sinks steadily, in a completely damped motion, without any bounce at all. The secret of this damped motion lies in the built-in decompression valve, which delivers a controlled release of the clamping action until stabilization is achieved. Secure in the knowledge that the cage is held firmly as they embark, the miners certainly complete their shift in a happier frame of mind. What a difference in the case of the cement car. With the cage firmly clamped by the Levelok jaws, the car can be safely pushed out on a firm, level platform without any fear of derailment and a great saving in frustration and time. You will notice that after the car has exited the cage, there is still no shift in the position of the cage. When the air hose is released, the cage rises almost 50 centimeters in a controlled action. This is the equivalent of the rope stretch caused by the 6-ton cement car. The onsetter once again levels the cage floor. The air hose is applied and the Levelok is activated and grips the cage firmly in position. This time, with the cage locked, an 8-ton locomotive is pushed in. Once again, notice that there is no shift in the cage floor position as the loco enters over the rail gap. The operation is carried out smoothly, quickly and safely, with the minimum of effort and time. Again, there has been no change in the position of the cage from before and after loading. The air hose is released and the cage with loco sinks steadily in a controlled manner as the rope stretches under the added load. Speed, security and safety. These are the 3 cardinals that are at the heart and core of good mining practice. The Levelok cage holding system, supplied by Horn Hydraulics, ensures that these factors are maintained at the critical hoist transfer points in your mine. You cannot afford to be without them.